So how are we going to express the probability to find the particle in C, taking into account the fact that the particle can go through both holes at the same time? So one way will be to proceed in analogy with something which we know could go through both holes at the same time. And if you think about it, that will be the case of a wave. A wave will be able to propagate from A to B and to C by going through both holes at the same time. It would make no sense to say, oh, I have a wave which only goes through one hole but not the other. It actually goes through both holes. So we can use analogies with waves. And indeed, if we were sending a wave from A to C via two holes, we will observe such oscillation, which we will call in this case interferences. So our intuition tells us to use some tools which are used to describe wave dynamics in order to build our formalism for quantum physics. For instance, if I want to describe a special wave, I can use a cosine function with a phase, an amplitude, and a frequency. This is all good, but often we have more than one wave and we need to take their sum. Not only that, but usually we don't measure directly the amplitude, but an intensity or an energy which is usually the modulus squared of the sum of the amplitudes. As you can see, this gets very quickly complicated. So people have introduced a very clever trick, which is to transform these amplitudes into complex numbers, which turn out to be much easier to manipulate. Now, of course, you will tell me that we never measure a complex quantity or an imaginary number. Everything we measure in physics is always give us a real number. So if I want to, for instance, get the physical amplitude, I will have to take the real part of this expression. Or if I take the intensity or the energy, which is a modulus squared of the amplitude, that will naturally be also a real number. For instance, if I take the sum of these two waves, the intensity or the energy of the resulting wave is modulus squared of this sum, and that's a real number. And it turns out to be much easier to use such an expression with complex numbers because it's easier to manipulate exponentials than cosine or sine functions.